Hello everyone. So today we are going to do the mock test for our chapter chemical kinetics, right? So let's see that how you can solve the mock test. So basically you can visit our website sathee.puto.ai and there you can in the course for the JEE 2026 you can attempt the mock test for every chapter. Now for this chemical kinetics, let's start our mock test. Okay, so it's our first question. The question is saying that the units of the rate constant for a zero order reaction are. So the unit you have to tell for the rate constant of a zero order reaction. Okay, so if you remember, how can you find out the unit of the rate constants? So every order rate constant have different units. Okay, like zero order reaction have different rate constant unit. First order reaction have different rate constant unit. So if you define for a general reaction, the rate is given by K times A, which is our reactant to the power X, B, which is another reactant to the power Y. Right, and X and Y may or may not be equals to the stoichiometric coefficients of our reactants, right? So A and B are representing the reactant concentration. This is the rate law for any general reaction, A plus B giving us C plus T, right? Now from here, if you write the value of K will be rate upon the concentration of A and the concentration of B. Right, now if you want to find out the K, that is rate constant unit, you have to find out the unit of this right hand side things. So rate can be defined as the concentration divided by the time, right? And this in the denominator we have already the concentration of the reactant present, so you can also write it as 1 upon the concentration, right? But here is the difference, that this concentration has a power n. N here is determining the order of the reaction. So X and Y, basically the sum X plus Y gives the order of the reaction. That's why here in the concentration power we write N. So if the reaction is a zero order, we put N is equals to 0, and this concentration unit will not going to contribute in the unit of the rate constant, only the concentration by time then we will have to consider. So here we have given that the zero order reaction rate constant you have to find out. So if you put n equals to 0, this concentration term in the denominator will eliminate. So concentration by time is the remaining thing. Concentration is given by mole per liter, right, divided by time is in the second. So it will be mole liter inverse second inverse, right? That means our first option will be going to be our correct answer, right? Okay, let's move to our next question. The second question is that the half-life, that is T half, for a zero order reaction will going to depend upon. You have to tell from the given options the factor on which the half-life, which is represented by T half of a zero order reaction, will going to depend upon. Okay, the options as you know given are that rate constant K only, the initial concentration R naught only, both K and R naught, or neither K nor R naught. If you know the T half for a zero order reaction is given by R naught, that is the initial concentration, divided by 2K, right? So T half is determined by R naught and the K value both. That is why we have our correct answer, that both K and R naught. Okay, for this question our correct answer is going to be both K and R naught. So let's move to our next question. This question is that which of the following is an example of a zero order reaction? So you have to tell that from the given options which is the example of a zero order reaction. Okay, so the first option is decomposition of H2O2 in the aqueous solution. Second option, the hydrolysis of ethyl acetate in the acidic medium. Third option, the decomposition of ammonia on a hot platinum surface at high pressure. Fourth option, the reaction between H2 and I2 to form the HI. So you have to tell from these given four options which is going to tell you an example, or which is example of a zero order reaction. Okay, so if you know some properties of zero order reaction is not going to depend upon the concentration of the reactant. Okay, that is the one property of the zero order reaction. As the name says, it has zero. That means the reactant has a power of zero. That means the reactant concentration is not going to determine the rate of a zero order reaction. So we have these four options, in which our correct answer is this third one, that is the decomposition of NH3 on a hot platinum surface at high pressure. Okay, why it is so? Because in this process the catalyst play a very important role. So in the zero order reactions, basically the concentration is not going to determine so much rate. The catalyst will going to participate in the reaction. It will going to provide its surface for the reaction to carry out, right? So NH3 will going to attack on the surface of the catalyst, which we are using here as hot platinum surface. Okay, so on the platinum surface, that is catalyst surface, the NH3 is going to attack, and the catalyst surface is going to be in the saturated state. That means all the activated sites which are present in the catalyst are going to be filled, okay, by the NH3 molecules. All the active sites will going to be occupied by NH3. Now if you increase more concentration, or if you provide more concentration of the reactant NH3, that will not going to change the reaction rate, okay, because the catalyst is reached out to the saturation, and that's why here the catalyst is determining the rate, not the concentration of the ammonia. And that's why at high pressure the ammonia decomposition on the platinum hot surface is going to be our example for a zero order reaction, because it is showing us that this process is not depending upon the concentration of the reactant. It is depending upon the reactivity, or the catalyst activity, okay, catalyst surface activity. So our correct answer is going to be the option third. If you see the another options, the decomposition of this in aqueous solution, the hydrolysis of ethyl acetate in acidic medium, in these options the concentration is going to play an important role, and that is why we are not considering them as our correct answer. Okay, so for this question our correct answer is option third. Let's move to our next question. Okay, now this question is that for a zero order reaction, plot of concentration of the reactant, that is R versus time t, gives a straight line with. So if you draw the graph for the concentration of reactant versus time for a zero order reaction, it will going to give you a straight line. It is already given in our question. Okay, you have to tell the slope and the correct intercept. Okay, you have given four options. In the first option, it is saying that slope is equals to plus k and intercept is equals to r naught. Second, slope is equals to minus k and intercept is equals to r naught. Slope equals to minus k and intercept equals to ln r naught, or slope equals to plus k and intercept equals to 0. Okay, so you have to tell about the correct slope and the intercept for a zero order reaction plot of concentration of reactant versus time. Now if you consider so slope is going to be between the concentration of the reactant and versus time. So basically for zero order reaction, if you know the concentration of the reactant has no such significance, okay, the concentration of the reactant is not going to affect the rate of the zero order reaction, right? So So basically, if you know the integrated rate law for a zero order reaction, which is going to be R equals to minus of KT plus R naught. This we have integrate from that equation, which is minus dr by dt is equals to K times R naught, right? Now R naught power is going to be 0 because this is a zero order reaction. So the remaining thing will be minus dr by dt is equals to K, right? So minus dr will be equals to KT, right? And then when you integrate that equation, you will going to get this integrated rate law for zero order reaction, that is R equals to minus KT plus R naught, right? So this equation or this integrated equation is going to determine the graph between the concentration of reactant, that is R, versus the time t. Okay, so if you compare this with the straight line equation, y equals to mx plus c, we already know y is going to be our R, so R is already at the left hand side. Time is going to be our x. Okay, that means this is our x. That means with the product form, whatever is present with the t with x is going to be slope. So slope is going to be m is going to be minus k, and this is going to be our c, that is intercept. So intercept is going to be R naught, right? It is correctly represented in the option B, that is slope is equals to minus k and intercept is equals to the R naught, the initial concentration. Okay, that means our correct answer is going to be option second. Okay, so let's move to our next question. So this is the question 5th, and it is saying that for a zero order reaction, the reactant is converting to product. The integrated rate law is given by, okay, so we have already mentioned that R is represented by reactant, P is represented by product, and this is a zero order reaction. Then the integrated rate law will be, so as we have discussed, that minus dr by dt, you can write it as the K times the concentration of reactant, but here it is a zero order reaction, so concentration of reactant is going to be have power 0. Now this will become equals to 1. So minus dr by dt will become equals to the K. You can write it as minus dr equals to K dt. Right? From here, you have to integrate this equation. Okay. Then you will get R equals to minus KT plus I. I is integration factor whose value we will determine at time t equals to 0, which is going to be R naught. Okay, so R finally will be minus KT plus I plus R naught. Okay, so this will be our going to be this equation will going to be our integrated rate law for the zero order reaction. Okay, so it is correctly present in our which option? This second option, R equals to R naught minus KT. Okay, and hence our correct answer is going to be the option option second, R equals to R naught minus KT. Okay, so this is going to be the correct representation of integrated rate law for a zero order reaction. Let's move to our next question. So this question is asking us that the decomposition of the ammonia NH3 on a platinum surface at high pressure is a zero order reaction because, so the ammonia decomposition into the N2NH2 basically on a platinum surface at high pressure is a zero order reaction because, so you have to tell the reason that why this process is considered as a zero order reaction. Okay, so we have given 4 options. The first one is that the rate depends on concentration of ammonia. The platinum surface gets saturated with ammonia molecules, making the rate independent of concentration. The reaction occurs only in the gaseous phase, or the activation energy of the reaction becomes zero at high pressure. So you have to tell from these four options that which reason is correctly representing the explanation for this decomposition of ammonia on the platinum surface at high pressure to be a zero order process, zero order reaction. Okay, so if you see the first option, which is saying that rate depends on concentration of NH3. So if you know, zero order reaction is not going to depend upon the concentration of the reactant, right? That means rate will not going to depend upon the concentration of ammonia. So first option will be wrong. If you see the third option, it is the reaction occurs only in the gaseous phase. So the reaction occurs only in the gaseous phase. That is not going to determine, or that is not going to correctly tell us that yes, it is a zero order reaction. If it is only occurring in the gaseous phase, that means it is in same phase reaction. Okay, it can be first, second, or zero order reaction. Okay, so this is not the correct reason to explain that ammonia decomposition on a platinum surface is a zero order reaction. So this is also eliminated. Fourth option, activation energy of the reaction becomes zero at high pressure. Okay, so activation energy of the reactions becomes zero at the high pressure. Then this is also not going to be active. From the activation energy, you cannot determine the order of the reaction. Activation energy doesn't explain the order of a reaction basically. So this is also not the correct reason. Activation energy tells you about the relationship between the rate constant and the temperature difference mainly. Okay, and that means that this fourth option is also going to deleted or also going to eliminate from our list. The remaining is option B. The platinum surface gets saturated with ammonia molecules, making the rate independent of concentration. So here in this option already it is mentioned that rate will become independent of concentration, and that is what happens in the zero order reaction, right? Also it is saying that platinum surface will going to get saturated with the ammonia molecules. What does it mean? That when you do the decomposition process of ammonia on the platinum surface, the ammonia will going to decompose into the N2 and the H2 molecules. So first of all, the ammonia is going to attack on the surface of the catalyst, which is platinum here. It gets, or the surface of the catalyst gets saturated. That means the active sites, whatever the number of active sites which are present on the surface or which are available on the surface of the catalyst is going to be fully filled with the ammonia molecules. That means the platinum surface will get saturated. That's what the saturated word means here. And if you even provide more concentration, increase the concentration of reactant, that is ammonia molecules, nothing will going to change the rate of the reaction because the active site is already occupied. The catalyst become already saturated. Only those amount of ammonia molecule which get absorbed on the catalyst surface is going to react and is going to give us the product. Okay, so this process, that means the increasing or decreasing the concentration of ammonia is not going to affect the rate. Okay, the surface of the catalyst is basically, or the catalyst is basically going to affect the rate of the reaction, and that is why the correct reason provided for the statement that decomposition of ammonia on platinum surface at high pressure is a zero order reaction is basically present in our option B. So option B is going to be our correct answer. Okay, so let's move to our next question. Now this question number 7 saying us that the conversion of molecules from X to Y follows a second order kinetics. If the concentration of X, that is reactant, is increased to 3 times its initial value, how will the rate of the formation of Y will change? Okay, so we have given that the molecule are converting from X to Y. X is a reactant, Y is a product. Okay, so X is converting to Y, and this process is following a second order kinetics. Okay, so as I said that we have different orders of the reaction, 0 order, first order, second order. Okay, now we are also given a condition that if you increase the X concentration, reactant concentration, to 3 times of its initial value, that means if X is the initial value, it will become 3X. How will rate of formation of Y will going to change with this change of concentration of reactant? So we have provided 4 options. The first option is that the rate will remain unchanged. Second, rate will become 3 times. Third, rate becomes 6 times. Or fourth, that rate will become 9 times. So you have to tell that which option will going to be the correct answer, right? So if we solve, you have to consider here the rate law. Okay, the rate law is given for a reaction as, here we have given the reaction that X is converting to the Y. X is reactant, Y is product, right? So rate law for this reaction is going to be equals to rate is equals to K times X concentration, right? This is going to be the rate law, right? Now we have mentioned in the question that it is following a second order kinetics. That means the here power in the concentration of X is going to be 2, because it is a second order kinetic reaction. So order is going to be second order, that means N is going to be 2, so X to the power 2. Now we are saying that concentration of X is increased to 3 times. So rate will become K of 3 of X of whole square, right? Concentration become 3 times means X become 3X. 1 mole become 3 mole, right? So 3 multiplied by X, remaining thing will be same because it is still a second order reaction. So whole square. Now if you take this 3 outside, 3 to the power 2, because both will be having the power 2. So 3 power 2, X power 2. Okay, 3 power 2 will be 9. So 9 K, remaining thing will be X square, right, is equals to rate. Let's say this is rate dash, because rate prime, okay, because this is the new rate we have determined after the changing of the concentration of X. Now if you see, this is the first expression and this is the new expression. So Kx whole square is our rate. So you can write it as that rate prime is going to be equals to 9 times of the rate. You can write it like that, right? So new rate becomes the 9 times of the initial rate. Okay, and hence our correct answer is going to be the C, last option, D option. The rate will become 9 times. On increasing the concentration of X by 3 times, the rate is becoming 9 times. Okay, so this is going to be our correct answer. Okay, so let's move to our next question. Okay, so this is a question number 8 and it is saying that consider the decomposition of hydrogen peroxide, that is H2O2, catalyzed by the iodide ion in an alkaline medium. Given reaction we have where the hydrogen peroxide is catalyzing by the iodide ion in alkaline medium, giving us 2 molecules of water and the 1 molecule of oxygen. Rate equation is given by rate is equals to K times the H2O2 concentration multiplied by the I negative, that is iodide ion concentration, right? This is the rate given. Which of the following statements is correct about this reaction? Okay, so from the given 4 options we have given 4 statements actually, which you have to find out that which is the correct one about this explanation, rate and the reaction given. So options are, the reaction is termolecular because it involves 3 reacting species. The molecularity of the overall reaction is 2. The reaction is first order with respect to the hydrogen peroxide and 0 order with respect to iodide ion. Or the molecularity of the slowest step is 1. So if we see one by one, the first option is saying that reaction is termolecular. Termolecular means the molecularity of this reaction is 3. Why? Because it involves 3 reacting species. Okay. So if you see, we have 2 molecules of H2O2 and they are like reacting and converting to 2H2O plus O2. So in any case, this is not possible that 3 reactants is, like reacting with each other and forming our products, right? So molecularity cannot be 3. So if you define the molecularity is defined as the number of the molecules that are colliding with each other, okay, to give us a like product, okay, the suitable product. So in the first option, it is saying that the molecularity is 3. Why? Because 3 reacting species are involving. No, there are not the 3 reacting species that are involving. That's why this is going to be eliminate. Okay, we will see the second option later. Third option is that reaction is first order with respect to H2O2 and 0 order with respect to I negative. So I negative is a catalyst. You cannot say with with respect to catalyst something is 0 order, or so H2O2, it is saying that reaction is first order with respect to H2O2. How can you say that? Okay, H2O2, like if you write the rate law for any reaction, it is going to be K times the concentration of the reactant to the power X. That X may or may not be equal to the stoichiometric coefficient that are present in the reaction. If you consider that it is equal, then it should be 2, because here it is 2 reactants of H2O2, right? If X cannot be equal to 2, then it can be anything. What I was saying, that rate is determined by the concentration of reactant H2O2. Okay, so here we have already mentioned the rate in the question, which is KH2O2 I negative, right? Okay, now if you determine from this given rate, what is the rate of the reaction with respect to H2O2 and with respect to I negative, it is 1. Okay, because H2O2 has power 1 in the concentration, that means the reaction is going to be first order with respect to H2O2, and similarly I negative has power 1, that means I negative will also going to have the order of the reaction as 1 with respect to I negative. Okay, so this reaction is, this option, the third option, is also going to be wrong. Okay, last option is saying that molecularity of slowest step is 1. Okay, so if here we have to consider the slowest step, so the 2H2O2 molecule reacts with I negative, convert to 2 water molecule and oxygen. Basically this reaction happens in the two steps. The first step is the slowest one, which is also a rate determining step, in which the hydrogen peroxide molecule is going to react with the catalyst in the alkaline medium, which is I negative. It will form some intermediate, and then that second step will going to follow, where the final product will going to be obtained. Okay, so first step is the slowest step, where the H2O2 molecule is going to react with the I negative molecule. That means 2 molecules are going to react with each other, and as per the definition of the molecularity is the number of the colliding molecules that are doing the suitable or particular like collision and converting to the suitable product, okay, the correct product. So if you determine the molecularity in the slowest step, it is not going to be 1. Okay, something is going to be reacting with something is going to be collide with something, so 2 molecules should be there to define the molecularity, right? So molecularity of slowest step in this reaction cannot be 1. This option will also going to be eliminated. Remaining is only option second, which is saying that molecularity of overall reaction is 2, which is going to be the correct answer. because as I said that this reaction will happen in the two steps. The first one will be the slowest step, and that is also the rate determining step, and on that we will consider the molecularity or the rate. Okay, so from that slowest step the rate will come. Okay, and from that step the molecularity of the overall reaction will come, which is going to be 2, because two molecules, that means one of H2O2 and another of I negative, will going to react with each other, collide with each other to form the intermediate. That is why the molecularity of overall reaction is going to be 2. Hence the correct answer is going to be option B, yeah, option 2. Okay, now let's move to our next question. Okay, so this is question number 9. It is saying that for the reaction 2NO plus O2 giving us 2NO2, what is the molecularity of this elementary reaction? So this is the given reaction in which NO reacting with O2 giving us NO2. The question is that you have to tell the molecularity of this reaction. So as we have just discussed, that molecularity is defined as the number of molecules that are undergoing the process of effective collision to give us the suitable product, right? So here in this reaction, if you see two reactants, that is two NO molecule and one oxygen molecule, are going to collide with each other, right? That means the molecularity of this elementary reaction is going to be 3, right? So unimolecular means one molecularity, that is wrong. Bimolecular means two molecularity, that is also wrong. Cannot be determined is also wrong, because our third answer is the correct one, that is termolecular, which is just saying that the molecularity of this reaction is 3. Hence this third option will be our correct answer. Okay, moving on to our next question. A reaction has the rate constant K equals to 5.6 times 10 to the power minus 3 second inverse. What is the order of this reaction? So we have given that a reaction, let's say, has the rate constant K value as 5.6 times 10 to the power minus 3 second inverse. Okay, you have to tell the order for this reaction after looking at this given rate constant value. Now if you have given the rate constant value in the question, then how can you determine the order from that? So the trick is you have to look upon at the unit of the rate constant given. Okay, here the unit is given is second inverse, and we have discussed that how can you determine the unit? Basically by this expression, which is rate equals to K times the concentration of the reactants, right? So rate constant will be rate upon the concentration of reactants. So its unit will be concentration upon time, which is the unit of rate, multiplied by 1 upon the concentration of reactants. So concentration, but to the power n, which here n is explaining, or n is determining, or n is for the order, n is representation of the order of the reaction. Here the order is not mentioned, right? But how can you find the second inverse as the unit? Only when this time will remain, this concentration will cancel out totally. That can only happen when n is going to be equals to 1, right? That means first order reaction, right? So concentration will cancel out when n equals to 1, and the unit will going to be second inverse. This time will go in the numerator. Okay, this is how you can determine the unit of the rate constant, and from the unit of the rate constant you can determine the order of the reaction, because they are interrelated. Okay, so here if you put n equals to 1, concentration term will cancel out, time will only remain in the denominator, which will go on the numerator, become second inverse, and the rate constant has this unit of second inverse. That means the order of the reaction is n equals to 1, that means the first order. Hence the correct answer is here first order, at the second option. Okay, so let's move to our next question. So this question is saying that for the reaction 2NO plus O2 giving us 2NO2, rate law determined experimentally is rate equals to K times NO to the power 2 times O2. You have to tell the overall order of the reaction. We have 4 options: 1, 2, 3 or 0. So you have to tell the overall order of the reaction. The rate law is already there, so you can easily determine the overall order by seeing or by looking upon the rate law. Rate is K NO to the power 2 O2 to the power 1. Okay, so this power sum will going to determine the order of the reaction. Here power are 2 and 1, so 2 plus 1 is 3, right? So that means the order of this reaction will going to be equals to 3, and hence our correct answer is going to be option third. Okay, moving on to our next question. So this question is that the reaction CHCl3 plus Cl2 giving us CCl4 plus HCl has the rate law rate equals to K times CHCl3 multiplied by Cl2 to the power half. What is the order of the reaction with respect to Cl2? Okay, now here we haven't asked about the overall order. We have asked about the order of the reaction with respect to the chlorine molecule. This also you can determine by looking at the rate law. Rate law is given as like this, where the chlorine having the power half. I said power will determine the order of the reaction. Okay, if you talk about the overall order, that is going to be the both power sum. But here we have asked about the order with respect to chlorine. So chlorine having the power 1 by 2, that means the order for this reaction is going to be half. Half means 0.5. So our correct answer is going to be option B. Okay, let's move to our next question. For the reaction 2NO plus O2 giving us 2NO2, rate law is experimentally determined to be rate equals to K times NO whole square and O2. If concentration of NO is tripled and concentration of O2 is doubled, so by what factor does the rate of the reaction increases? You have to tell that. So rate is K NO to the power 2 multiplied by O2. It has given that NO is tripled. So K 3NO to the power 2. O2 is doubled. So 2O2. Okay, now if you solve this, 9 3 times square will be 9. So 9 will come out. 9NO whole square, and 2 is as it is. So 2 will also come out and out. Okay, so this is the same thing, only the constant are 9 times 2 KNO whole square O2, right? And this is the initial equation for the rate, right? So the only thing is 9 times 2 is 18. 18 times rate is going to be increase. Okay, so question was that by what factor rate of reaction is going to increase. So reaction rate is going to increase by 18 factor. 18 times the initial rate will become the final rate, right? So our correct answer for this question is going to be the 18, that is the third option. Okay. Okay, so that is how you can solve our mock test provided in our website. Okay, and practice for this chapter, that is chemical kinetics. We have covered here 1 to 13 questions with the explanation. You can go through that and practice yourself, try yourself.